This is the homework for 1060, 61, 66, and 68. For problem 1060, Cherise can fill lemonade cups at a rate of 4 cups per minute. So I have cups over time, 4 cups per minute. Part A asks how many cups can she fill in 6 minutes? So we don't know how many cups in 6 minutes. So this is a proportion problem, proportional relationship. So you can just cross multiply. X multiplied by 1 is X. 4 multiplied by 6 is 24. So she can fill 24 cups in 6 minutes. For 60B, how many cups can she fill in 10 minutes? So remember, her rate is 4 cups per minute. So how many cups in 10 minutes? Cross multiply. 1 multiplied by X is X. 4 multiplied by 10 is 40. So she can fill 40 cups in 10 minutes. In problem 1061A, you need to find the measure of the exterior angle X. In order to do that, you can use the exterior angle theorem that the two remote interior angles, the sum of those two angles, equals the exterior angle. So we have 38 plus 90 equals X, this angle. So 38 plus 90 equals 128 degrees. So X has a measure of 128 degrees. For 61B, I needed to find the measure of angle X. And I was given the measure of this angle, which is 82 degrees. And so the first thing I did when I'm trying to find the missing measures of parallel lines cut by a transversal is I draw the beach balls. And this was the given measure. So I did blue, orange, and then the corresponding or corresponding angle are congruent. So this is also 82, blue, orange, corresponding. So I have corresponding angles. And remember, a blue and a yellow, these are supplementary angles. And supplementary angles equal 180 degrees. So I know that if this is 82 degrees, 82 plus 98 is going to equal 180 degrees. So I subtracted 82 from 180 to get 98. And I could fill in the rest by vertical angles are congruent, corresponding, alternate exterior angles, alternate interior angles are congruent, and then same side interior angles are supplementary. They add up to 180. And remember, when you finish, a yellow and or an orange and a blue, the supplementary angles are going to add up to 180. But all 4 of them should have a sum of 360 because a full circle has a measure of 360 degrees. In 1066, we need to find the volume of this cone. And remember that the formula for the volume of the cone is V equals pi r squared multiplied by the height divided by 3. One way I remember it is veggie pies are too hot, so I'll cut it into thirds. So now I'm going to substitute r with the radius, and the radius is 8. If the dashed line went all the way across, then that would be the diameter, but it's halfway across, so it's the radius. So we have the radius squared multiplied by the height, which is 20. So we have 8 squared multiplied by 20 divided by 3. 8 squared is 64. 64 multiplied by 20 is 1,280. 1,280 divided by 3 equals 420 and 73 hundredths repeating, pi inches cubed, or cubic inches. That's the exact value. Now to find the approximate value, we're going to multiply this by 3.14. And the volume is approximately 1,339 and 93 hundredths cubic inch. For 1068, we need to simplify each expression. So you need to distribute this exponent. When you have a power raised to a power, you need to distribute. So in order to, when I distribute this 2, I put a little line here to remind me that I'm multiplying. When you have a parenthesis, you're multiplying power to a power. And I put a 1 here because anything to the first power is itself. So I'm distributing this 5 to the first power multiplied by 2, 1 multiplied by 2, and 3 times 2. So 1 multiplied by 2 is 2, 3 multiplied by 2 is 6. 5 squared is 25, x to the 6th power. In problem 1068b, we need to simplify the expression. 14/21 simplifies to 2/3 because 14 divided by 7 is 2, 21 divided by 7 is 3. When we're dividing exponents with the same base, so we have variables with the same base, a and a, you subtract, and this division bar is reminding you to subtract. So you keep the base, a, 3 minus 4. Same base, b and b, keep the variable b, 2 minus 3. So 3 minus 4 is -1, 2 minus 3 is -1. Now we take the reciprocal of a to the first. Since it's in the numerator, it's going to go down to the denominator. And b to the -1st, it's also in the numerator, it's going to go down to the denominator. If it was the negative exponent was in the denominator, it would go to the numerator. So now we have 2 over 3ab. In 68c, we have 2 times m to the 3rd times n to the 2nd times 3 times m, and I put the exponent 1 there, so we have a as a placeholder because I want to make sure I can see all of the exponents. By putting a 1 there, anything to the first power is itself, so I'm not changing the value of it. And then multiplied by n to the 4th. Now, commutative property of multiplication states that we can move around the terms without changing the value. For example, 1 multiplied. For example, 2 multiplied by 3 is 6, and 3 multiplied by 2 is 6. So I'm going to set them up as, with like terms. So I have 2 times 3, and then m to the 3rd multiplied by m to the 1st, n to the 2nd multiplied by n to the 4th. So now, if you remember, when you multiply integer exponents with the same base, you add the exponents. And here's an example. M to the 3rd is m multiplied by m multiplied by m, and m to the 1st is m. Well, this is m to the 4th, 1, 2, 3, 4. So we have m to the 3rd multiplied by m to the 1st, so that's 3 plus 1. We're adding the exponents. The n's, same base, 2 plus 4. So we end up with 6m to the 4th, n to the 6th.